Today, we are going to start talking about OR statements. So we've talked about compound inequalities, but mostly we've spoken about AND statements. So now we're going to start talking about OR statements. So right there on page 6 of your packet where it says OR inequalities, you can write down that one or both of the statements are true. That is what an OR statement is in mathematics. So just some life examples. So in everyday language, I don't think we think about OR as the same way as we do in mathematics. So in math, either one or both of the statements are true makes the whole statement true. So for example, Miss McCaffrey is a math teacher, or dogs have 7 legs. This part is true. This part is obviously false. And so because one of them is true, though, that makes the whole statement true. Okay, so my second one says Miss McCaffrey is a math teacher or Miss Sims is an English teacher. This one is true. This one is true. That makes the whole statement true. But the difference here is, like, we might not say in real life that this is a true statement, but in math we're going to. So one statement can be true or both. And our last one, Miss Sims is a math teacher. False. Miss Sim hates math. Or Miss McCaffrey is an English teacher. Also false. I'm really bad at spelling. So that makes this whole statement false. So just wanted you to get an idea kind of of what OR statements are all about. Okay? So now if we look at our packet, our first example says x is greater than 2. I guess the way it's written, is x is greater than 2. Or x is less than or equal to -1. I just want you to take a second to kind of understand how we're going to end up graphing that. So we're going to break it into 2 parts. So my first part is the purple part, where x is greater than 2. So if I were to graph that, I have x is greater than 2. So again, we know I'm not good at drawing the lines. We're not going to color it in because it doesn't have a less than. So far we know that x can be anything that's bigger than 2. Our next part says x is less than or equal to -1. So that's this part right here. I'm going to shade that in. All right. And so now if we were going to do them both together, I would take this part here. And I also would take this part here. So I'm really taking them together. So what the green statement is all about is if I have both of them together. So if I have this and if I have this. So the numbers that would make this true. 3 would work because it's this part here. -9 would work because it goes with this part over here. 1 would not work because it's right here. So for this to be true, either this part needs to be true, x needs to be bigger than 2, or this part needs to be true. X is going to be smaller than -1. So that's different than an AND graph, because an AND graph is all about where they overlap. But these, they don't need to overlap, because an OR statement means that either one of them is true or both of them is true. All right, so if we turn the page of our packet, we should have our first example, which is x plus 1 is less than 4, or x minus 1 is greater than or equal to 3. So if we wanted to solve that, we're just going to do it in 2 separate parts. I'm going to subtract 1 so that I get x all alone here, and I get x is less than 3. Okay, so we know that it's going to be numbers that are smaller than 3, or our other option is this inequality. So I add 1 to both sides, and I get x is greater than or equal to 4. All right, so if I was to graph that, I'm going to first graph this piece. So x is less than 3. So I go over to 3. I'm not going to color it in, and I'm going to go this way. Anything smaller than 3 works. I'm going to also do this second part. X is greater than or equal to 4. I go over to 4. Ooh, I should have made this a little bit smaller. So it's all of these things here. So a number like 5 would definitely work because it's on this side over here. That goes with this inequality. A number like 3.5, that's smack dab in the middle of here, despite the fact that I drew a giant circle. That would not work because it's 3.5 is neither smaller than 3 or bigger than 4. Okay, so when we're solving OR inequalities, our possible solutions are either if this statement is true or this statement is true. So if we look at this, we should see that we have an infinite amount of answers. Okay, so x could be 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, all the way to infinity, and all of those fractions that are in between there. Similarly, it can be smaller to 3, all the way down to negative infinity, and all of those small numbers that are in between them. There's a possibility, an infinite number of possibilities for x to be. All right. We have a couple more examples that we're going to go through together. So our next one is x plus 14 is less than 15, or x plus 9 is less than or equal to negative 10. So again, when I solve these, I'm just going to do each inequality by itself. So to get x all alone, I'm going to subtract 14. So I get x is less than 1. All right, so if I want to graph that, I can. X is less than 1. All these here. Okay, and now this one here, to get x alone, I'm going to add 9. So I get x is less than or equal to negative 10 plus 9 is negative 1. So I get x is less than or equal to negative 1. I'm going to do it in a different color. In a second, you'll see why. Okay, so we have x is less than or equal to negative 1. Okay, so when we graph these two separate parts, so this one that was in green and this one that was in black, we should see that they're overlapping. And the reason for that is any number that's smaller than negative 1 must also be smaller than 1, right? So if I have the number negative 10, because that's smaller than negative 1, that's also smaller than 1, because negative 1 is smaller than 1. So everything that's smaller than this one is definitely going to be smaller than this one. So if we want to try to be as general and clear about what our answer is, instead of writing x is less than 1 or x is less than or equal to negative 1, that being our answer, since anything that's smaller than negative 1 is also going to be smaller than 1, I can say that my solution is just all of this stuff here. So I'm going to say that my solution is x is less than 1. So that one's a little bit trickier, right? So this is more understanding of what the whole thing is. It's a little bit trickier. So when you have an OR graph and they overlap, because an OR statement has either one part being true or both of them being true. If they overlap, then you can just put the one that covers everything. So in this example, this part here takes care of this. So my answer is just x is less than 1. That one's a little bit trickier than the first one that we did. Okay, so to sum up, again, OR graphs, OR statements, compound statements and inequalities are where one statement is true or both of them is true. We're going to solve each inequality independently, and then we're going to graph both of them and just take a look to see what our solution set is. Okay, so for this one, we definitely should recognize where we have x is less than 1, we have infinite answers that could be solutions to that inequality. You have one more in your packet, number 3. There are m's there. That problem I'm going to have you try out on your own, and we'll talk about it when we get to class. All right, have a good night. Bye.